Hello all, welcome to our channel. Please subscribe to our channel. Today's topic is introduction to pointers in C as per request. Let's straight away get into introduction to the pointers in C. Pointer is a variable just like other variables like int a, int b, int c, variables of C, but only difference is unlike the other variables, it stores the memory address of any other variable of C. This variable may be type of int, char, array, structure, function, or any other pointers. For example, 1. Pointer p, which is storing memory address of an int type variable. That look at this code. Int I equal to 50 and int pointer p equals to address of I. Okay. Pointer p, which is storing memory address of an array, int array 20. So int in brackets pointer p of 20 is equal to address of array. That means it stores the first address of array ARR. And next example is pointer p, which is storing memory address of a function character display void character pointer p void equal to address of display. That means pointer p is of type character, which will be storing the memory address of a function called display. Pointer p, which is storing memory address of struct type variable. So struct abc int a float b and var is the struct variable. The name of struct abc pointer p equal to the address of that struct variable. Okay, here p is storing memory address of struct variable type. Okay, of where. So coming into the arithmetics in deeper, we already made on this, but we'll look into the broad perspective of the arithmetics. Rule 1. Address plus number equal to address. Address minus number is equals to address. Address plus plus is also equals to address. Address minus minus is also equals to address. Plus plus address, that means post increment of address, will be equals to the address. Minus minus of address, that is post decrement of address, is also an address. If we will add or subtract a number from an address, results will also be an address. New address will be like new address is equal to old address plus number into size of data type which pointer is pointing to. Suppose I have a character data type character I have a pointer, so plus number into the size of, that is 1 byte. New or you can say like new address is equal to old address. Suppose it is pointing to 2000 minus 1 into 1 byte, that is 1999 will be the new address. Let's look into a small program. Hash include stdio.h in main integer pointer p equal to integer pointer 1000. PTR is equal to PTR plus 1. Printf %u PTR. Return 0. That means it has to print the PTR, value of PTR. Value of PTR will have address of it. That's obviously 1002. Because plus 1 is the PTR equal to PTR plus 1. That means integer is 2 bytes, 1000 plus 2 bytes. What is the output of the following program? Double pointer p, here p is equal to p plus 3. So printf %u comma p equal to p plus 3. So 3 p equal to, previously it is 1000, right? Previous address is 1000 plus 3 into since this is double will be 8 bytes, right? 3 into 8 will be 24. The output would be 1024. what will be the output of the following C program? So float array 5, 1.1f, 2.2f, 3.3f, float pointer ptr 5, ptr is equal to address of array. So printf percentage u ptr, ptr equal to ptr plus 1. Here since it is ptr is pointing to one array is of 5. So 4 bytes float type. So 4 into 5 is 20. So it increments by ptr equal to ptr plus 1. That means it would be 20 plus 1000. That equals to 1020. So type def struct abc int for pointer a, double b, unsigned b, unsigned char c, and abc in main function. No? Abc pointer ptr struct pointer ptr equal to 1000. So ptr is equal to ptr plus 2. Here the size of that particular variable is of struct type. Struct consists of how many? This thing ptr is equal to ptr plus 2 is the obligation. Obviously size of the array will size of the struct will be added and it equals to 1026, since 1024 plus 2, right? So instead of looking at it, use a compiler and check it, parallelly write it on paper, then you can understand what will be the output of the following program. Type def union a b c character pointer character near, and this is one more union type variable, and I am accessing that union type variable, that is 1000, and ptr equal to ptr minus 4 into 10, that equals to 40. 1000 minus 40 is 960. Obviously the output would be the 960. We should consider the size of that variable. Here the variable is of type union, so highest in that this thing is double, right? So double size will be considered as a size of that union, whereas in struct it's the cumulative of all the variables inside a structure. Fine. What will be the output of the following program? Let's see. Float pointer display int. So max equals to 5. In the main, float pointer of pointer ptr int. We are calling that function ptr equal to display. That means it will be holding the address of display function. Pointer ptr 2 comma 2 printf percentage u ptr is equal to ptr plus 1. So we have to print ptr. Here float function will, the address of float function will be holded. Obviously when you are trying to increment that, it obviously gives an compiler error. It will point to, it can point to anything, right? ptr. So you get an compiler error. So coming into the rule 2 of arithmetic, difference arithmetic with pointers. Earlier we saw addition, right? Address minus address is equal to number. So if you suppose I'm living in the street with the address number of 850 and you are living at 835, 850 minus 835 gives me 15, right? There must be 15. You are 15 houses away from my house. Okay, so if you similarly here address minus address gives you a number. If you will subtract two pointers, result will be a number. Mathematically it can be shown like this: if two pointers of same type, then address 2 minus address 1 is equal to simple subtraction of two addresses, size of data type which pointer points to. Let's get into the example program. So here in this program, if you see in main, integer pointer p is pointing to, is having an address of 1000, and integer temporary pointer is equal to p equal to p plus 2, and print f temp and p. Then difference equals to percentage d p minus temp return. So since the temp will hold 1000, it will be print 1000 and 1004, since it is plus 2 into 2, that is 4. 1000 plus 4 will become 1004. So temp will be printed as 1000 and p will be printed as 1004. But the difference you are getting here is difference between p minus temp will be 2. The here two pointers p and temper are of the same type, but both are pointing to integer data type. So obviously difference divided by, according to the formula, size of that particular data type. Here it is int. Int is occupies 2 bytes in this case. It depends upon the compiler. So 4 divided by 2 is 2. 1004 minus 1000 will give me 4 divided by size of that particular data type. Here in this case it is integer, so 4 divided by 2, obviously you get a difference is 2. Let's see what's the output of the following program. Float p, which holds address 1000, and q, which holds address 2000. So this is a float type. So here also the same stuff, 2000 minus 1000, the difference will be 2000 minus 1000 divided by size of float. Size of float is 4, obviously. So 2000 minus 1000 is 1000 divided by 4, that is size of float is 4 bytes. So divided by 4 gives me 250. Okay. What will be output of this? I have a struct of this type. It has signed char c, short int, and long double. So cumulative of those will be the size of my struct. See, size of struct here is character is of 1 byte, and integer is of 2 byte, and double is of type 10 byte. Double will hold 10 bytes. So obviously the total size of struct here would be 13. So let's see the difference. Q minus P will result in 2000 minus 1000 will result in 1000 divided by 13, that is nearly to 76. Okay. What would be the, so here we have a union. Union is having the maximum out of for pointer. It is having a for pointer variable character for, that is of 4 bytes, and a constant volatile I, that is 2 bytes, and long int is 4 bytes. So maximum out of it will be 4. Obviously the size of the union would be 4. Now see the difference. 2000 minus 1000 is 1000 divided by 4 will give me 250. Let's see to this program. Constant volatile array 4 equals to 0, volatile pointer p 4 of 4 equals to address of array pointer q. This is also address of array. We are incrementing q plus plus, that means it increments by twice we are doing it, and then printing f. Twice means 4 into 2 will be constant volatile will be of 2 bytes, right? 4 into 2 gives me 1000, will give me 16. So p will print as 1000 and q will be printed as 1016. The difference equals to q minus p divided by size of constant volatile. Size of constant volatile here is 4 into 2, since we have it would be 8, right? So 16 divided by 8 will give me result 2. Hence the difference is 2. Coming to the rule 3, illegal arithmetic with the pointers. So we already discussed in our previous this thing, address plus address is always illegal. You cannot um, add address to address, address into address. We cannot add multiply address into address, or address divided by address. Address slash address is illegal, and address percentage address is illegal. Let's see the output of this program. Integer I equal to 5, integer pointer p, where p points to the address of I, and q is whose address is integer pointer q 2. So printf percentage d p plus q. So we are trying to print two addresses, that is address of I and address of, integer pointer 2 is also an address. So we are trying to add these two. Obviously it gives me a compiler error. Rule 4, we can use relation operator and conditional operator between the pointers. If two pointers are near pointer, it will compare only its offset address. Okay, let's check with this program. We'll see what would be the output. Integer near pointer p equal to some address, and integer pointer q equal to some address. If p double equals to q, printf equal, else printf not equal. So if two pointers are near pointer, it will compare only its offset address. Offset address here is 5555 Obviously it will print equal, right? So we can use relation operator and conditional operator between two pointers. If two pointers are far pointer, it will compare both offset and segment address also, not just offset. It will compare even the segment. See, with the near, it will just go with offset, but with far pointers, it will go with both offset as well as segment address. Segment address in this case is 0x0a 0a000 and 0x0a 211, which is not equal. Hence it says we are not equal. So if two pointers are huge pointers, it will first nominalize into the 20-bit actual physical address and compare to its physical address. So let's check what would be the output of this particular program. Integer huge pointer p equal to this address, huge pointer q equals to this address. Okay, so by default, according to this rule, it will first nominalize into the 20-bit actual physical address and compare to its only the physical address. So obviously it will print equal, because 0x0a and 0x0a it will compare and just simply gives me equal. Rule number 5, bitwise arithmetic with pointers. So we can perform bitwise operation between two pointers, like address and address is illegal, address or address is illegal, and address cap address is illegal, and complement of address is illegal. So let's see with an example. Here I have I equal to 5, j equal to 10. Pointer p points to the address of the, will hold the address of I, and q holds the address of j. Printf p or with q, which is illegal. Obviously it gives me compiler error. Rule 6, we can find the size of a pointer using size of operator. Wow, we'll see how with this example. So I have a near, far, huge pointer p. Okay, size of p is 4, and size of p, I mean single pointer p, is obviously 4, and double pointer p is 2. This is how we check near pointer, far pointer, huge pointer p. Okay, we'll see this array pointer to array of functions in the next uh, stuff. I hope this was quite useful to you. Please subscribe to our channel if you really liked the concepts to support us. Thank you.